In terms of announcements, don't forget your first homework assignment is due today if you're turning it in late. There's no penalty, but make sure that you get it in. Your midterm has just been released right now. You have a week to do it. You are going to be implementing Connect N, which is like Connect 4, except you can get to control the size of the game space and how many pieces in a row you need to win. Get started on that very, very early. It's going to take you some time. It took me about 2 hours to finish it. So I don't know how long it's going to take you. But the Tic Tac Toe is a great place to get started from. Any questions before we begin? Yes. It's just like another homework assignment that's worth more. Okay. That's rock, paper, scissors. We're doing Tic Tac Toe. Yes. Yeah, you can work with a partner. And let's see, where did we leave off last time? So we still need to figure out if the game is over. We need to be able to change the turn, and we need to be able to declare the results. We probably also need to do one more thing, which is display the board again, so that it shows up. So what do you guys want to do next? Do you want to change the turn, figure out if the game is over or not, or declare the results? Okay, let's figure out if the game is over. So that's going to be over here in Tic Tac Toe. Bool is game over. Is it going to change us at all? Modify ourselves anyway? Figure out if the game is over? Nope. So const. So what makes the game over? Again, think high level. Don't get too much into details. Somebody wins. Or there's a tie, right? So we might say return win or tie. Great, we're done. Right, but now we're able to break down each of these statements in a little bit more detail. So bool, maybe we call it game 1 instead. So what are the possible ways to win? Horizontally, or vertically, or diagonally. So we could say return horizontal win, or vertical win, or diagonal win. Great, right? That problem's done. But now, again, we came up with 3 more problems that we need to solve. Okay, so how can we figure out if there is a horizontal win? Okay, sure, but like an actionable plan? Right, well, we need to go through and we need to look through each one of the rows, right? And if all of the elements in the row are the same, but not spaces, right, then we should be done. Does that make sense? So how can we go through each of the rows? Right now, currently as we have it, we can't directly iterate through the board. Like using like a for each loop. We can, though, make ourselves return iterators over the board if you want to, so that we can iterate over each one of those rows. So you might do something like using iterator equals std : vector of std : string iterator. I'm using these again, these type def, so that I don't have to keep typing out std : vector, of std : string : iterator, because that's like a huge pain in the butt to write every time. So what we can do now is we can implement a few functions. We have like a iterator, right, begin, an iterator end, a const iterator C begin. Is probably not going to modify ourselves at all, and a const iterator C end. Any questions about what I've done here so far? And remember, iterator is just another name for that big a long thing. Okay, so begin. Well, that's pretty easy. We could just say return board state dot begin. Function complete. Return board state dot end. Return board state dot C begin. And finally, return board state dot C end. So you can notice that the type right here, we can say it is it's Tic Tac Toe game. That's our namespace, : board, : const iterator. So anywhere else that we want to like specify this type inside of our game, we can say a board : const iterator to name that type. Also, it turns out that implementing these functions, begin and end, we'd also have to implement a different version of begin and end as well. One that returns the const iterators as well, and that would allow us just to do the for each loop. But I don't want to get into that right now. We'll talk about it more when we talk about iterators themselves. So we need to go through each of the rows, right? So for auto row iter equals board dot C begin, row iter doesn't equal board dot C end plus plus row iter. And so I should probably check that the first element in this row is not a space, because if it's a space, right, I can't have a win on this row. Agreed? So what I might say over here is I might have like auto, element iter equals row iter arrow C begin. If star element, I think we can do go put one more function back over here on board. Code generate a getter character. So if it happens to be equal to a blank character on this row, like the first element is a blank character, what should we do? Skip it. So how do I skip it? Yeah, continue. Right? If this row is empty, right, or this row starts with a blank character, it doesn't mean that the rest of the row, right, any of the other rows couldn't have a win in it. Right? And then we might have another for loop. Or what we could probably do is if we pop over to here, and we look at C++ algorithm. So one of the things that we want to figure out is if all of the elements in the sequence, right, are something, and we want to see if they are all equal to the first thing, which maybe might make this a little bit tough to use. Yeah, probably it's going to make that one a bit tough to use here. But we kind of want to say like all of them are equal to the first one. But then we have to have a function that knows what the first thing is, and that involves doing more stuff, which is probably a bit too complicated for right now. So we'll just write another for loop. So we might have something like const char first element is equal to star element iter. And then we might say for element iter doesn't equal board. Oops. A row iter arrow c end plus plus row iter, right? If element iterator doesn't equal the first element, what should we do? There's no match. We could break. But we might also kind of need like a counter now. Because how else are we gonna like, because we know that if, you know, we can break out of this for loop right here if they're not all the same. But we need to know by the time that we run, like end up down here, were they all the same or not? If this was in Python, we could probably do it pretty easily using like a for else statement to figure out if we broke out of it or not. Not so easy as to do in C, but still pretty easy. We might have something like bool completed loop. True. Or maybe I want to say like this: all same is equal to true. All same is equal to false. Then if all same, we can return true. And then if we get all the way through this, we can return false. So what we did, right, is we're going to go through each element of the board, right? For each row in the board, for each element in that row. If the first character is a blank character, skip it. There's no possible way to win if there's the first character is a blank character. Otherwise, we check to see if all the elements in the row are the same. Check to see if they're all equal to that first character. If they are, right, then we could return true. Right? Otherwise, return false. If we think about it like this portion right here, what's this kind of sound like, right? We're trying to check to see if everybody in the vector is the same, right? All the elements are the same. So we might want to make that a method, right? Instead of having a standalone code. It is a big chunk, right? If all the elements in this vector are the same, then return true. Does that make sense? But we're running short on time, so we'll leave it as crappy code and we won't throw it into a function. But are there any questions here? Yeah.
That part tell us all the same.
Yes, because if all the elements in the row were white space, we don't have a win, right? But if we didn't skip it, then we would think that we did have a win. Anything else? Yeah. We don't care. So somebody won, right? But because the game is over if somebody wins, but I don't particularly care who wins. We can probably get the current player's turn, right? To see if once we leave this loop back up here, right? Once we leave this loop up here, then we can just declare who won the game or not. Does that make sense? Okay, so how can we figure out if we have a vertical win? Probably need to create one more function over here on our board. So how can we see if there's a vertical win? What do we need to do? Well, again, like we have the elements stored row by row, right? But we want to see if there's a win in the column, right? Which requires going across the elements of multiple different of the interior vectors, right? So we'd have to iterate through the columns, and it's probably going to have to be like an index-based for loop right now, so that we can go through each column first. Yeah. So again, remember we're generalizing this to be like n, like a game of n pieces in a row. So we're not always guaranteed that there's going to be 3. It still might be possible with iterators to do it, but if we were going to do that, we'd probably want to provide column iterators as well as row iterators in the board. But I don't want to do iterators right now for like actually implementing them. We can come back later and do that. So we're just going to use like an index-based loop right now. So we'd have to do something like, for int call is equal to 0, right? Call doesn't equal or dot get size, right? Because we know it's squared plus call. So again, we should still probably check to see if this element is a blank space in this column, then we can skip it. So if board dot at, and we want to see at, our row would probably be row 0, our column is column, or even better, if board dot is blank space, row would be 0, all. Again, once again, we can just continue, skip. Then otherwise, for int row is equal to 0, row doesn't equal board dot size plus row. And again, we're trying to kind of do that check to see if everybody is all the same. So bool all same is equal to true. If board dot at row comma call doesn't equal board dot at board dot at 0 call. All same is equal to false, and we can break once again. For loop ends here. If all same, return true. And then otherwise we can go down here and we can return false. Anything good? Any questions here? Yeah. Oh, yeah, great, thank you. Any other questions? Okay, so now we have diagonal wins. And the diagonal wins, right, they can only occur on those two main diagonals. That's the only way that you can get n in a row, right? So there could be two. First question to you guys is, that a left diagonal win or a right diagonal win? Left, right. Enough. So we could just do something like return left dag win, or there could be a right dag win. Agreed? And again, by breaking these problems down into smaller and smaller problems, it makes our lives easier in solving them, as opposed to having to do everything at once. So this is we're checking for. So how can we check to see if we have a win along this diagonal? Yeah. So the indices have to be the same to do 0, 0, 1, 1, 2, 2, 3, 3, right, etc. going down. And again, we still have that kind of like exact same check. But again, like the first one can't be a blank space. So if board dot is blank space 0, 0, right, upper left hand corner, what can we do? Return false, right? Otherwise, right, we need to go down that main diagonal. So for int I is equal to 0, I is less than board dot get size plus I. Again, we might have something like const char first char is equal to board dot at 0. And then here we can say like if board dot at I doesn't equal first char, we can just return false. And then down here, good, return true. Right, because again, there's only one main diagonal where you can win on that board. So we only have one diagonal to check to see if all the characters are the same, but not blank spaces. Any questions here? And we just searching down that main diagonal. And then we have our right diagonal win, which I'm going to steal a lot of this code. Basically, I'll steal all of it. But now, where is our first character at? So it's like in the upper right-hand corner, right? So what row would it be on? Row 0. And then its column index would be the number of rows minus 1 or the number of columns minus 1, which would be board.getSize minus 1. Right, that's the upper right-hand corner. And then again, we can throw that in here as well. And then we want to start, again, I could be equal to 0, right? So here we want to go like row 0, row 1, row 2, row 3, right? Like So we're trying to check here. So I needs to go 0, 1, 2, 3, right, as we go down the rows. But over here, right, we need to go 3, 2, 1, 0 to go down the other direction. Right, moving to the left. But we can still start I as 0, I is less than board size, right? Row still starts at I. What should this guy over here be for the column? Yeah, board dot get size -1 minus I. And that will allow us to traverse down that diagonal. Do you guys have any questions? Yes. So is your question, why is it the -1 here, or why is it minus I? Well, -1, right? How many, how big is this board over here? It's like 4 by 4, right? But we want to start at index 3, so we -1 because of the zero-based indexing. Any other questions? Okay. So notice that we haven't even done tying yet, but notice like here's just figuring out if we've won the game. Can you imagine having all of that just in a single function trying to understand what's going on there? Right? You know, we went from like line 146 to line 66. That's like 120 lines of code. Something like maybe a little bit less, but 80 lines of code. That's still a lot to have for a single function, but breaking each one down to smaller segments, and we should probably have some better comments in the horizontal one and the vertical ones to explain what's going on. But it's a lot easier, I would believe, with smaller functions than having this as one huge function extended across all these things, even if they were still broken down into these separate segments. Does that make sense? Okay, so how can we figure out if there is a tie? Right, so there's not a win, right, and the board is full, right? So here we might say, it depends on how you want to do this, but we could say like not win or not game 1 and board dot full. Right, but now we have to just go define like what does it mean for the board to be full? Bool full const. So there are a couple of different ways that we could do this. So there are two different ways. One, we could do it with a counter. So every time we call this function, wherever it went, back over here. Every time we call the set function, right, we could increase the number of elements that are inside of us by 1, right? And then we could be just full if the number of elements, right, is equal to our size squared. Another option that we could do is we could check to see if there are no blank spaces inside the board. Which option would you guys like to do? Have the counter? Check that there are no blank spaces. I think no blank spaces 1. It's still going to be slightly less efficient because we actually have to search through the entire board again. But I agree, it is pretty easy to understand. So we could do something like for auto row iter is equal to C begin, row iter doesn't equal C end, plus plus row iter. For auto call iter, or maybe actually going to do this with the Okay, so now we can figure out before this went on. So now we have to be able to change the turn, not chog the turn. So what does changing the turn look like in Tic Tac Toe? Right, we have a player turn variable. Like when player turn is 0, it's the first player's turn. When player turn is 1, it's the second player's turn. So how can I change the turn to make it the next person's turn? Yeah. So we're not counting the number of turns. It's just 0 means it's player 1's turn. 1 means it's player 2's turn. Yeah, that would work, right? Or we could just have like an if statement, like if turn is equal to 0, turn equals 1, right? Otherwise, turn equals 0. Or if you want to be like clever, you could do something like player turn is equal to player turn plus 1, modded by players dot size. So think about this. If player turn is 0, right? 0 plus 1 is 1. 1 mod 2 is 1, right? 1, so if player turn was 1, 1 plus 1 is 2. 2 mod 2 is 0, right? So if it's 0, it becomes 1. If it's 1, it becomes 2, right? Or you could write it out with the if statements as well. Does that make sense? So great, we're now able to change the turn. And the next thing that we need to be able to do is, where am I at? Back toe. We need to figure out who won, right? We need to say, you know, somebody won, or somebody tied, or I guess those are the only options. Somebody won, and if somebody did win, who won? And if nobody won, there was a tie. So we might do something like lazy, like if tie. Oh, that's nice. I don't have to rewrite that. Tie game. Right. Else. One thing to note here that's kind of like a little bit tricky with this part is how this loop is structured. So let's say it's currently player 0's turn, right? Let's say that this move that they make wins the game, right? We're then going to change the turn. So it becomes player 1's turn, or it becomes player 2's turn now. And we come back up and the game is over. So when we go down here to declare the results, whose turn is it? It's the loser's turn, right? Do you guys like it that way, or do you want to restructure our loop so that it ends with the winner being the winner? Are you okay with the loser being the current turn? Or would you like it when the game ends that the winner is the current turn? Okay, so let's say we want to do that. How can we change this loop to make that happen? Say it again? But if we change turn at the beginning, the people will be playing the wrong piece, right? They'll start with player like 2 instead of player 1. I guess it would be possible if we started with the second player first, and then we change the turn at the beginning to make it be like the first player's turn. But I think that makes things like a little bit kind of complicated, but it could work. If not, win what? Change turn. Or what we could do is we could restructure our loop a little bit, right? We could just have like while true after the person makes the move, if game over break. Right? So we could change this to be something like while true right? We make the move, and you can say something like if, oops, game over, break. And now, because we don't change the turn here, we'll actually end with it being the current player's turn. I kind of dislike the fact on this one that it makes it look like not so understandable up here at the top, but such is life. So now it'll be the winner's turn, right? So you can say else like std : cout get current player dot get name won the game. And then we probably need a new line. Make it look nice. Any questions? I think there's one thing left that we have to do, and I don't think we actually did anything here in players, right, for constructing them. But back over here in Tic Tac Toe, if we look at our constructor all the way at the top, right, we do make 2 players, so we do need to like declare a player constructor that probably is going to go ask the user for their information to get things done. So over here we might now have like player. That's our constructor. And we're going to need to include IOStream. So what should we now do in our constructor? Yeah. Well, yeah, but we're going to do that in the player's constructor for right now. So we might just do something like, std : cout, enter your name. And then, std : cd into name. Okay, that'll do it, I guess. So now when that vector constructor gets run at the beginning, right, it'll create 2 players. This constructor gets run to ask the people for their information. So now for the moment of truth, is it probably have some mistake in here somewhere. I wouldn't expect it to build. There's probably some other bugs over here somewhere. But one thing is we go ahead and we play. Oh, we forgot to actually run the game. So I want a Tac-toe game, : Tic-tac-toe. We don't need to include this anymore. Don't need this anymore. We have your game. We have our game.play. Great, we're done. Right? Keep main simple. Making the game, play the game. Okay, good. We do have some errors. So we have undefined reference to, yeah, I guess we need to say, like, maybe we'll start with a 3x3 that needs an asterisk for the space. Not how it works. Oh, because it's square. Okay, let me just go look back at our constructor. I guess we just have to say the size. It should be explicit. Okay. It builds. So you enter your name. I might be M. My piece is also M. This person is S, and their pieces will be X's. Right? Over here, I'm going to say it's probably kind of hard to know like where you want to play in. Oh, also we should kind of note that, Oops. There's some leftover stuff. This is some leftover stuff I know from where. Where's my players at? Because we did some reads into these variables, we actually left the new line character at the very end. So what we need to do is have an std : : where is it? Cn. Oh, I missed a colon here. Why is that wrong? That should hopefully get rid of that error there. See, now that's not asking it too many times. So where do you guys want to play in? Maybe like 1-1 or yeah, 1-1. And now I have an M there. Maybe this person wants to play in 0-1. Maybe I try to play in 1-1 again. I'm not allowed to because there's something already there. I might try to play in 0-2. So I get the M over there. This person might be bad, and so they play in something like no, that would be 1-0. Oops. Apparently you had a segmentation fault or something weird happened. But we'd have to debug that to see what, Well, we'll debug that in a second, but I'd say that this is an interface is kind of hard to work with because I don't know which spot is which. Agreed? So we probably might want to update our display, and then we'll go in and then we'll debug and we'll see why 1-0 breaks things. So this is going to be back here in board, in display. So what might make this a little bit easier to show to the screen? Right, if we printed like some numbers along the top and some numbers down the side. So how can I go about printing those numbers out at the top? Well, we don't necessarily need a new vector. We can just do that with a for loop, right? So we might have to say like print the row headers or column headers, it should be. And we might just, say for int I equals 0, I less than get size plus I. Right, that'll get us 0, 1, 2, 3, 4 going across the top. And now for each one of these rows, we probably want to print out an index. So we might have something like int row index is equal to 0. And then so at the beginning of each row, we're going to see out the row index with a space after it. So we'll get the 0, 1, 2. Yeah. Say it again. No, because if there were three things, we'll do, the size will be 3, so it'll be 0, 1, 2. 3 is not less than 3, so we'd stop. So we print out the row index, and then this one is going to need a little bit of work here to make it look a little bit prettier. So for const auto reference, these are elements in row. space after it, and then once we hit each row, we can print out another new line. And then finally, the other thing that we're probably going to need to do is put a little space here. I think 2 spaces will do it. So you enter your name, right? We're like doing M, and I'm doing M's, and there's S, and she was doing X. And I forgot to increment my row index each time. Row index plus plus. Oh gosh, where am I at? But you can see that that's going to look a lot nicer, right? For people to work with. And again, notice like these spaces, I don't have them stored. These row indexes, I don't have them stored as part of my board. They're just extra stuff that I print out. So what you have stored doesn't have to be directly what you display to the user. You can store extra stuff, you can hide stuff from them, right? You might need more information to get things to print out nicely. But it's a lot easier to work with that, work with our vector of strings that don't have any spaces internally inside of them. So I can just say index 0, 1, 2, 3 instead of having to deal with this. Now we should also go see like why am I breaking? So we'll throw it to the debugger. And I was M and playing M, and you were S and you're playing X. When I did 1, 0, something broke. And hey, it's breaking right here for me. That's nice to know. Probably we can see that the reason for the mistake is right here. I did row iterator instead of element iterator to go to the next one, right? Because it should be like for each element in there. I accidentally incremented the wrong counter. So now if I come back and again M, and I'm playing M's, and S, and I'm playing X's. If I do 1, 0, hey, it doesn't break anymore. Maybe the next person plays at, say, 2, 1. Maybe now I try to play at something like 1, 1. That seems good. Maybe they're going to be like, well, I'm going to play at 1, 2. And then I decide to play at 2, 0. And they're like, oh no, I'm going to block you at 0, 0. But apparently I got a lot better at Tic Tac Toe since last time. And I won the game. And like, if we're really going to be testing things out here, which we don't unfortunately have time to do, we would really want to make sure that we tested like all the possible win combinations. Like, am I able to win vertically, horizontally, diagonally, right? Am I able to win on every single row if I have time to test that, right? We would also need to exercise some things like, like here we didn't do like any input validation checking on the user's inputs, so we should probably do that. One thing that we'd probably want to make sure is that like the people didn't choose the same character, right? Player 1 and player 2 both can't be X's, so we should probably add something in there to check for that. This person might be Sally. Sally, she might be playing Y's. We have to try like negative indices, like -1, 2. Does Bob work? No, right? Some things don't seem to be working, like 1, 2, 3. That also doesn't work, right? So you want to exercise some error testing as well to see like if everything that can possibly go wrong. If it does happen, you're able to handle it correctly. We'll get into new topics starting on Wednesday, but hopefully you have a better understanding of how like object-oriented programming can help you organize a problem to make solving it a little bit easier.